Hey, everybody. Hope that you guys are having a good Thursday. Hope that week two of the semester is going pretty well for you. Um, so this is our fourth lecture, and we've covered a good bit of material. We have today's lecture, and then lectures next week, and then we have our first exam on, I believe it's the 17th. Um, so next Tuesday and Thursday, those lectures are going to be asynchronous. What I mean by that is I'm going to have those posted as or no later than um, Tuesday morning at 8 a.m. and Thursday morning at 8 a.m. So I want to do that so that you guys have more of an opportunity to review those. But what that means is we will not have our regularly scheduled Tuesday and Thursday meetings. So that 2 p.m. time, that's your opportunity to watch those videos, um, or that's kind of a reserved time to watch them, or you can watch them before that. Um, I'm going to be posting those as soon as I can. And then next Friday, my plan is that at, let me see, at Friday, the, let's see, today is the 5th, so tomorrow's the 6th. No, Friday the 13th, at approximately 1 p.m., we'll have a review session. Now, that's outside of our regularly scheduled time. So I'm going to record this and I will post this on our Canvas page. So this review session I'll send out the link beforehand. So like 12:45, I'll send out the link. If you want to join, you're more than welcome to. Alternatively, you can post questions to the discussions on Canvas. Um, I will be preparing a review guide for you. I will post that on Canvas. Um, so exam one is that would be the 17th. Review guide will be up before or up no later than that would be Friday 13th. So prior to that at 1 p.m. Okay. I see that some folks unmuted themselves. Did you guys have a question? If you have any questions, feel free to drop them in the chat. But that's my plan for next week. I'm going to have this review session so we can talk about the exam, give you a heads up about what's covered on it, and kind of work through some practice problems. Basically, the some questions that are not going to be on the exam, but similar to questions that will be on the exam. So it'll be a good opportunity to review that. And then any questions that you have, you can put them in the discussion on Canvas or email them to me, and I'll be sure to answer them during that review session. My plan for this review session is basically 1 p.m. to roughly 1:45 p.m. Okay. Well, if there's no questions, I'm going to go ahead and get started and proceed through this bulk of material called organic chemistry. So last time when we were talking, one of the things that was brought up was the study of organic chemistry, and we talked about kind of specific types of organic molecules. And we talked about hydrocarbons, molecules that are basically made up of, well, hydrogen and carbon. And there, sure, there are hydrocarbons that also have oxygen, but there are, a hydrocarbon is a molecule that is predominantly carbon and hydrogen. Now, of those hydrocarbons, there's a couple of different types of molecules. There's alkanes, alkenes, alkynes, and cyclic hydrocarbons. Now, oh, am I recording? Yes, I am. Good. Cyclic hydrocarbons are commonly known as ringed or ring structures or ringed molecules. Now, when it comes to organic chemistry, one of the toughest parts of organic chemistry is known as nomenclature. So, figuring out how to name a compound. Now, we're going to start out, we're going to go through all of these four different groups, and we're going to come up with and talk about the basic rules of organic nomenclature for hydrocarbons. Now, any molecule is going to have a very technical name, but we're going to focus on these four different major groups. So, alkanes, they have a nomenclature scheme that follows this pattern. They have a stem, and that would be based on the number of carbons. And then to that, they're going to add ANE when it's an alkane. So, as an example, if your molecule has one carbon and it is an alkane, that means it is commonly known as methane. Okay. Now, something like this right here, CH3OH, that's not going to be an alkane, but instead that's going to have a different name. And we'll talk about those in our in next week's lecture. We'll touch on what do you call it whenever it has this OH group instead of a hydrogen. But when we talk about alkanes, we have molecules with single bonds only, and nothing but C and H. So an alkane has no oxygens, no chlorine. The only atoms that alkanes have are carbon and hydrogen. That's what this this second line here. The carbons are always saturated. So whenever I think of or whenever I hear the word saturated, what I think is everywhere that a hydrogen could go on this carbon, it's there. So methane, carbon likes to have four bonds, and it is only going to have four hydrogens coming off of it. Next up is a molecule that has two carbons. It's going to follow this pattern where we have number of carbons. So in this case, the N here would be 2. Then we put a 2 in here, and that's going to give us the formula for the number of hydrogens that this alkane can have. So what that means is 2 times 2 plus 2 equals, well, 2 times 2 is 4, plus 2 equals 6. And this is a formula that is true for every single alkane. Now, what does ethane look like? Ethane has two carbons here and here, and then each carbon has one, two, three hydrogens. One, two, three hydrogens. So that's where those hydrogens are going to go. Now, before I display propane, let's come up with, and I'm going to scribble this out, and I'm going to scribble this out. Let's use our formula down here to figure out how many hydrogens that we need for a molecule of propane with three carbons. Let's use our formula. How many, and you can add to the chat and ignore this, like I said, and ignore this. How many H's does a three carbon alkane have? 8. You're absolutely right. Now, what does that molecule look like? Well, the way that you draw an alkane is you draw out your three carbons, 1, 2, and 3. Now, these carbons are all going to have a bond between each other. So you're going to make a chain or a main chain of carbons. So we've got one carbon-carbon bond, another carbon-carbon bond. Okay. Now, each one of these carbons is going to have four bonds to it. So this carbon on the far left, one, two, three. So I've drawn three places that hydrogen's going to go. And then here's my fourth bond. My fourth bond is a carbon-carbon bond. Okay, I'm going to erase that little added line that I put there. And now my central carbon, that already has two bonds. So how many hydrogens will that central carbon be bound to? Go ahead and add to the chat if you know. How many hydrogens will that central carbon be bound to? Carbon likes to have four bonds. You're absolutely right, Jessica. Well done. So H, H. This carbon that I'm underlining right here has four bonds to it, two hydrogens and two carbons. So that's how it reaches that four total. Now my carbon on the far right, well, that has one carbon-carbon bond. So how many hydrogens is it going to be bound to? You're absolutely right. H, H, H. Okay, so this gives us our formula of C3H8. Now, our last molecule here, butane, using the same formula, we got to put a 4 in there. So this is going to have a formula of C4H, and then 2 times 4 plus 2, H10. So our strategy for drawing this is going to be draw our main chain of carbons. So there's our C4. Now we've got each kind of, I like to call them bookend carbons. There's 1, 2, 3, hydrogen, hydrogen, hydrogen. That's three of our carbons. So now, just to keep track of everything, minus 3, we've got 7 left to draw. Hydrogen, 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 minus 3. Now we've got 4. 1 hydrogen, hydrogen, minus 2. We got 2 left to draw. Hydrogen, hydrogen, 0. Okay, so there is our molecule. Now, the question that you should expect to see on an exam would be something like 34 carbon alkane will have how many hydrogens? Well, we use our formula. C lower 34, H is going to be, go ahead and add this to the chat if you know this answer. 2 times 34, 68. You're absolutely right. H70. There you go. That's all there is to drawing and putting together an alkane. You've got nothing but single bonds. So I'm going to add here only single bonds. In addition to only having single bonds, that means you also only have carbon hydrogen and carbon carbon bonds. You don't have any carbon carbon double bonds or triple bonds or anything like that. Alkanes are pretty simple. Everything that you see here is everything that you or all the foundational information that you need to know about alkanes. And there's our butane and there's our propane. Now here what we have are properties of alkanes. So let's take a look at some of these properties. One thing that's worth noting is let's talk about our melting point first. Melting point and the trends of melting points. We start out with methane, which has one carbon and four hydrogens. That has a melting point of a negative 183 degrees Celsius. So this is a solid. Methane is a solid at negative 190 degrees Celsius. That's super cold. Okay, so methane will transition from a solid to a liquid at negative 183. Now, what point is it going to convert from a liquid to a gas? Well, our boiling point is negative 162. So at 23 degrees Celsius, is methane going to be a gas or is methane going to be a liquid or a solid? Go ahead and add to the chat if you know the answer to that. Is it going to be a solid, liquid, or a gas at room temperature? It's going to be a gas. You're absolutely right. So at RT or room temperature, 23 degrees Celsius, methane is a gas. Okay. Now, if we go through the list, ethane is also a gas at room temperature. Propane, gas at room temperature, which has anyone ever had a propane tank? Yeah, it's a gas. It's compressed and condensed into a canister. Butane is going to be a gas at room temperature. Pentane, however, pentane, and then another one that you might be a little bit familiar with, is octane. Have you ever seen or used octane that's in its liquid form? Absolutely. Octane, part of what you put into your gas or put into your car as gasoline. That's going to be a liquid at room temperature because it's not going to evaporate or convert from a gas to, or it's not going to convert from a liquid to a gas until the temperature is above 126 degrees Celsius. Liquid. There we go. So, what I want you to recognize here is that your boiling point goes up. Does anyone recognize a trend where your boiling point is going up? Looking at those different molecules, okay, methane has one carbon, pentane has five carbons, octane has eight carbons. What can you say about the boiling point and the number of carbons? The boiling point goes up when dot dot dot. It goes up when there are more carbons. You're absolutely right. Great answer, Alondra. So boiling point goes up as number of carbons goes up. That's a fantastic trend to recognize. And as the same thing is true for melting point. Melting point and boiling point go up as the number of carbons go up. Okay. Now, with these different molecules, with these alkanes, we can make modifications to them. And what that means is what we're looking at over here, all of these are considered to be linear molecules. They're considered to be straight chains. These are modifications that you can make to a straight chain. So what that means is you can have a molecule like this. And whenever you see something like this is known as the skeletal structure. This is depicting this right here. So this would be CH3, CH2, CH2, CH2. and CH3. Now, being able to convert from this to this is definitely something that is going to be a question on your exam. Every place that there's a point like that, that is a CH3. Every place that there's a point like this, that's an internal carbon. So think about those points as being carbons. Now, with that in mind, erase that, that, and that. Not every molecule is going to be a straight chain. Instead, you can have a molecule like this. Okay, and then that. Or you could have something that looks like this. Again, this point right here is CH3, where that is a carbon. This is a carbon. This is a carbon. What we do, there's a rule that we follow. There's rules that we follow. And it looks like this. For nomenclature of alkanes, you have to identify the length of it's known as a parent chain. And then you have to number that chain. The parent chain is your longest chain. And the way that you can do this pretty easily is by having your molecule, drawing it out, and then just numbering. Okay. This one in particular, here's an end, here's an end, here's an end. Okay. So what is my longest chain? Is it going from here to here? Or is it going from here to here? Well, what you do is you count them up. 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. Okay. So in either direction, whether it's this position right here or this position right here, it's 5 carbons long. That's how long this chain is. Now I'm going to clear all my writing on here because what you need to do is basically identify the length of that chain. Okay. You're going to number those atoms. Then what you're going to do is you're going to say, okay, well, here is my straight chain. Where is my substituent? Where is my group that comes off of it? Okay, well, right there. That group is one carbon. That is a methyl group. Just like CH4 is methane, we drop the ANE and replace it with YL. Then what we're going to do is we're going to give a guide as to where that molecule is. Okay, so we've got our main chain that is 5 carbons long, pentane. We have a methyl group. Where is that methyl group? Well, earlier I labeled it 1, 2, 3, 4, 5. But what we want to do is we want to give that methyl group the lowest possible number. And the lowest possible number is to say that it's on carbon number 2, as opposed to carbon number 4. So that numbering that I did where I started from the left and went to the right, that's not accurate. What I want to do is start from the right, in this case, and move to the left. So this molecule right here is called 2-methyl pentane. This gives me where is my methyl group? It's on carbon number 2. How long is my molecule? It's 5 carbons. It is pentane. Now, if you're thinking about, okay, back here we looked at methane, ethane, propane, butane. Well, where did pentane come from? This table right here, in addition to showing us the boiling points and the physical properties, what I want you to know is prefixes up to 8 carbons. So I want you to know methane, ethane, propane, butane, hexane, heptane, octane. Now these prefixes, meth, eth, prop, but, pent, hex, hept, oct, some of them are like shapes. If you think back to geometry class, how many points does a pentagon have? 5. How many carbons does pentane have? 5. How many points does an or how many sides does an octagon have? 8. If you're an Ultimate Fighting fan, you know that it's an octagon, 8 sides. So that's the range that I want you to know. Anything beyond that, I will provide you with that. So you should expect to see, as an example, you can see a molecule like this. One, two, that's 4 carbons. So this is propane. And then 1, 2. Okay. So for this molecule, what we want to do is we'd say, how long is this chain? 1, 2, 3, 4. Okay, that's one direction, or there's 4 and 5. Okay, so this would be an example of methyl because we've got 5 carbons, methyl pentane, because it's 5 carbons in that chain with one methyl group coming off of it. All right, so that's our nomenclature. You got to go through this process, identify the parent chain, number that chain, name the substituents, assign a number to that functional group, and complete the name. Now, these are challenging questions. I will give you some examples um, posted to our Canvas page either later today or tomorrow, just some examples that you can work through. Okay, so these are alkanes, nothing but carbons and hydrogens, nothing but single bonds, nothing but carbon, hydrogen, and carbon, carbon bonds. So this is a narrow scope of types of molecules. Now, here are some good examples. 1, 2, 3, 4, 5. Okay. If I started here or here, it's still pentane because it's 5 carbons. Now, when I start here, then I've got a methyl group coming off of carbon number 2. So this is 2 methyl pentane. This structure is also 2 methyl pentane. If that methyl group is on the right hand side or the left hand side, doesn't matter. It's still carbon number 2 because I wanted to give that methyl group the lowest possible carbon number. Now, if we go to this next molecule, we've got 1, 2, 3, 4, 5, 6, 7, 8. Does anyone go ahead and take a chance to name this molecule and add it to the chat? Perfect. 2-methyl octane. Great job, Alondra. 2-methyl octane. Now here, this one can get a little tricky. Let's start over on the left. 1, 2, 3, 4, 5, 6. 6 carbons. Well, are we running into a problem? Should it be 1, 2, 3, numbering from the right, or should I number from the left? 4, 5, 6. Well, what we need to evaluate here is where do we get our substituents here and here, the lowest possible number? Well, we get it by numbering from the left. Now, I'll give you a little bit of a hint. I'm going to erase these. Um, go ahead and try to name this molecule. Knowing that you have 2 methyl groups, how do you think that you would adjust your name to reflect 2 methyl groups? So we'll go back to our longest chain. Our longest chain is 6 carbons. So that's hexane, 6 carbons long. Okay. Then what do we have? We've got three. Oh, great effort, Alondra. I like it. 3-ethyl hexane. Close. Here's the thing. Where this gets a little bit tricky is this is a methyl group, and this is a methyl group. And where it gets a little bit tricky is we can reflect, or we can show that there's 2 methyl groups by saying dimethyl. So we're going to say dimethyl hexane, and then we're going to add a number to show where those methyl groups are. Both of those methyl groups are on carbon number 3. So it seems a little bit silly, but we're going to say 3,3-dimethyl hexane. So there's 2 methyl groups on carbon number 3, and they're both on carbon number 3. So we want to say 3,3-dimethyl hexane. If the methyl groups were on carbons 2 and 3, we'd say 2,3-dimethyl hexane. But that's all that we have to do for that molecule. Okay. Now, alkenes are a little bit trickier. We have the same formula with the stem, and those stems, I want you to know, are meth through oct. So 1 carbon through 8 carbons. Now, what an alkene is that it contains double bonds between, or sorry, a double bond between 2 carbons. So here what we have is ethene. That is 2 carbons because remember, meth is 1 carbon. Eth is 2 carbons. Now, my first question is, and add to the chat, can methene exist? A little bit of a spoiler on the bottom of the page. No. Alkene is defined by a double bond between 2 carbon atoms. Methene cannot exist because there's only 1 carbon. So it doesn't have another carbon that it can double bond to. Now, the carbons with a double bond are considered unsaturated, meaning they have a second carbon bond as opposed to hydrogen. The molecular formula is CnH2n. So if I'm drawing an alkene with 125 carbons, that molecule would be C125H250. Now, here what we have is we have a little bit more complexity. We're going to start out going the same way. This molecule right here is 2-methyl-3-hexene. Okay, so what we've got to do is we've got to come up with what is our main chain, or what is our longest chain of carbons? 1, 2, 3, 4, 5, 6. Okay, so 6 gets us the hex. There is 1 double bond, so we're going to call it hexene. It doesn't matter if there's 1 or 50 double bonds or 60 or whatever. If there is at least 1 double bond, we're going to use the ene suffix. The next thing that we're going to do is we're going to use the number 3 to show where that double bond is. So 3-hexene designates where our double bond is. Then 2-methyl is listed first because that gives us our lowest number. So 2-methyl-3-hexene. There's no way that we could get the methyl group to a lower number, nor could we get the double bond to a lower number. Now, if we look at our next molecule, 1, 2, 3, 4, 5. Okay. Now, in this case, what we're going to do is we're trying to get our double bond to the lowest possible number. So that's why we did not go 5, 6. Instead, we went 1, 2, 3, 4, 5. So that's where we got pentene. This is one pentene because our double bond is between, I'm going to renumber here, 1, 2, 3, 4, 5. Okay, so that's pentene, one pentene, and then 2 ethyl, because here is our eth our group is coming off of carbon number 2. I got a question in the chat. That's a great question, Jessica. So we start out reading left to right, but what we sometimes need to do is switch our numbering, because what our goal is when we're reading and we're listing out our numbers is to get functional groups. And those functional groups could be double bonds or methyl groups. We want to get the lowest possible number. So the way that I started out was I went 1, 2, 3, 4, 5. And you know what I would, okay, I'm going to go ahead and erase something real quick, and I want to give you the alternative name here. Okay, I see your question, Alondra, in just 1 second. Okay, so I could also, if I were to, another way of naming this molecule would be to say, well, it's pentene, and then 4 pentene, saying my double bond is between carbons 4 and 5, and 4 ethyl. Okay, so this is ethyl because this is 1 and a second carbon. So 2 carbons means F, or that's where you use F. So looking at this molecule, you could put together 2 possible names. One is what's shown below, 2-ethyl 1-pentene. An alternative is 4-ethyl 4-pentene. This number, or this one right here, is more correct because you get lowest possible numbers on the substituents. We say our double bond is between carbons 1 and 2. In that ethyl group, this guy right here is off of carbon number 4, or sorry, off of carbon number 2. So that's why we read in this case from right to left: 1, 2, 3, 4, 5. Now, this is, if you're looking at this and saying, man, that's confusing, you're right. Don't think, oh yeah, I should get this immediately. Instead, organic nomenclature, you have a couple of principles. This, for alkanes, you're trying to get the longest chain, and then you want to number it. And you want to name those substituents or functional groups and assign them not just a number, but you want to give them the lowest possible number. And then complete the name based on that. So I like to look at a molecule like this right here and basically try to put together, what are the possible names for this molecule? What I've written here are two possible names, 2-ethyl 1-pentene. Okay. Alternatively, 4-ethyl 4-pentene. Both of those identify this as a 5-carbon chain. Okay. The one right here, 2-ethyl 1-pentene, is more correct because we're using the smallest possible numbers to identify where different groups are. So on a test, if you read left to right for that one, would it be counted wrong because it is not simplified? Yes, it would. So on a test, I'll give you a multiple choice question. And so what I would recommend is, if this were on a test, you'd see both of these names. And I would just go with, okay, which one like is the stem right or wrong? Is it 5 carbons? Yes, that's right. Okay. But then between these two, which one gives me lower numbers to identify or lower carbon numbers? Well, this one right here. Okay, that's correct. Now, this is something that I'll give you some practice problems and some example problems. So keep your eyes out for those and just remember to follow the fundamentals of getting the lowest number and the longest chain identified. Okay. So this is tricky. Just be patient with yourself and be patient with this process. Okay. Now our next group are what are known as alkynes. Alkynes use the same stem, meth, eth, prop, bute, and so on, but it has a YNE. And I always like to think about these because ANE is single bonds. ENE is double bonds. Oh, yeah, absolutely. Let me go back. Sorry about that. So here what we have, and I'm going to do some erasing here. Okay. So for this question, let's see what we can do. We have, let's start left to right. 1, 2, 3, 4. Okay. That's 4 carbons. Now, just for the sake of argument, let's see what happens if I started here. 1, 2, 3, 4. Still 4 carbons. So what I'm looking for is I have a chain that's 4 carbons long. I'm going to jump back a little bit. 4 carbons right here. Butane. Butane is 4 carbons and nothing but hydrogens. Okay. Now this molecule, what else do I have? I've got ENE. Okay. So that means I've got a double bond. In this particular case, I've got 2 double bonds. So that's where we come up with butadiene. So but meaning 4 carbons. Ene meaning 2x bond. Di meaning 2x bonds, 2 double bonds. Okay. Whenever I'm writing a name, I like to start from the right to the left. So I like to kind of deconstruct it. But meaning 4 carbons, di meaning 2, ene meaning double bonds. So butadiene. Now, the next thing is I want to come up with the numbers that tell me where these double bonds are. Well, 1, 3 butadiene. So here's one double bond between carbons 1 and 2. Here's another double bond between carbons 3 and 4. 1, 3 butadiene. The last part of this molecule is I've got a methyl group. That methyl group is on carbon number 2. Okay. So 2-methyl 1,3 butadiene. Okay. Now that is the correct name for this. Let's look at this and come up with an alternative name for this. Well, in this case, if I numbered from right to left, what I would do, so this is my point with what we're about to do, is that you can't rely on, oh, is it right to left or is it left to right? Your goal is to get your your substituent group's the lowest possible value. Now, if I started from right to left, I'd say 1, 2, 3, 4. Okay. I've got two double bonds. So my name is butadiene. Next is, where are my double bonds? 1, 3, butadiene. Okay. What else do I have on this molecule? I have a methyl group. Methyl. Where is my methyl group? Well, it's on carbon 3. This is where you number right to left. And I'm going to circle this and say, this is incorrect. Why is this one better? Go ahead and add to the chat why this name is better, or you can say it aloud. Lower numbers. We got our methyl group a lower number. In this case, did we have any different numbers for our double bonds? No, they're both 1, 3. But our methyl group is 2 rather than 3. That's absolutely right, Jessica. Great job. So this is tricky. And so what I would do on your exam and quizzes and stuff is just look at the molecule and try to come up with what's my longest chain and how can I get the lowest possible numbers. That's kind of your goal with all these. Okay, now we're going to go on to alkynes. So alkanes are single bonds only. Alkenes are double bonds. Alkynes, well, I always just kind of think of it as a progression, like we're changing one letter. The NE remains the same. Alkanes, enes, ines. We got a 3x bond. Now, just as a little bit of a spoiler, there's no such thing as a quadruple bond. So that's where we stop. Anes, enes, ines, single, double, triple. Now, some molecules have specific names. They have common names. For instance, ethine is also known as acetylene or acetylene. Like if you've ever used like an acetylene torch. The formula calculation for these is C sub n H sub 2 times n minus 2. So if we had C125, it'd be H 250, or 2 times 125, which is 250, minus 2, which would be 248. So this was 2 times 125 minus 2. That's where that comes from. Now, alkynes are unsaturated hydrocarbons. These right here, so this right here is ethine. Those are 2 carbons. So what this looks like is C, 1, 2, 3, C, H, H. 2-butyne. This is a carbon 1. This is a carbon. This is a carbon. This is a carbon. So this is 4 carbons. YNE means there's a triple bond. Where is that triple bond? Well, it's between carbon 2 and 4, or 2 and 3. In this molecule's case, if we number from the left or the right, it's still going to be that double bond is still going to start at carbon number 2. So it's still going to be between 2 and 3, no matter which direction you look at it. This molecule on the far right, it's 1, 2, 3, 4 carbons, which is why we get bute. There is 1 triple bond. An alternative name for this molecule, based on the numbering that I just put together, would be 3-butyne. So we've got 1-butyne or 3-butyne. Which is the correct answer? Go ahead and add to the chat, A or B. A. I mean, you kind of have the the advantage of, well, A was already written on the slide, but then it gives you an opportunity to think about, oh, I could see this in a different way, but that different way could be wrong. And just like our previous example, where on our previous slide, answer option B is wrong because 3 is a larger number than 1. So that's why A is correct. Okay, now our last group. And so when it comes to questions that you can expect um, in terms of nomenclature, there's not really that many alkyne related questions that I'll ask, in part because alkynes are not super common, they're not super relevant. Um, Alkenes, more common. And so I would I would get comfortable with alkenes and alkanes. And then after that, look at alkynes. Okay. Our last group are the cyclic hydrocarbons. So for a cyclic hydrocarbon, all that you're doing is you're taking a molecule and you're adding cyclo. For instance, this is cyclopentane. We've got 1, 2, 3, 4, 5. This right here is pentane, what I just drew. Why isn't that cyclopentane? Add to the chat the structure that I just drew, that kind of spider looking molecule. Why isn't that cyclopentane? Because it's open. You're right. Great job, Alondra. It's an open molecule. It's not a ring. It's not a circle. So it can't be cyclo. So anytime you see a ring or basically a closed off molecule, we've got cyclopentane, cyclohexane, cyclopropane, cyclohexane, cyclobutane, cyclooctine. Oh, that's tricky because cyclooctine, we have a triple bond. So we get the YNE. Now, this is kind of like almost a metaphor, and it's the sort of thing that people say at weddings. Um, why isn't that we don't have a number identifying where that triple bond is? Why not? Anyone have any thoughts about why? Why is it not one cyclooctine or 5 cyclooctine? And I say people say this sort of thing at weddings because, yeah, exactly. It doesn't have a place to start. There's no beginning or no end of a ring, which is why, people are always like, and this ring I give you because, like our marriage, will have no beginning and no end. I mean, it does have a beginning, just happened. Um, but anyway, we don't have, like, there's not an appropriate number to give this because if this is 1, this is 2, well, why isn't this 1 and this 2? So it doesn't have that. Um, So that's more or less what there is to cyclic hydrocarbons. You use the prefix cyclo, then the stem, and then ANE or ENE or YNE to indicate what that is. Now, what you should expect from me in the coming days, I'm going to discard all of that, is you should expect from me a little worksheet with some practice problems. And I'm going to give you a key to it so that you can kind of put together what the actual names for molecules are. But you'll also have the opportunity to kind of come up with what would be the incorrect name and the incorrect numbering for a molecule. Um, that's what I have today. Like I said, no meth through oct, so 1 carbon molecules all the way up to 8 carbon molecules. Be able to do the calculations with the number of hydrogens, because that's going to be on exams and whatnot. Um, does anyone have any questions right now? All right, well, I'm going to stop the recording.